We are starting section 1.7, and the first topic in 1.7 is about 3 types of symmetry that a graph can have. And one thing that's very important to note is that at this moment, we're not necessarily restricting ourselves to talking about functions. Many of the graphs that we're talking about will be functions, but not all of them will be. So the first type we've seen in one of our parent functions. If I have y equals x squared, or actually if I have y equals the absolute value of x, both of these are symmetric about the y-axis. The left side of the graph is just a mirror image of the right side of the graph. So this is symmetry about the y-axis. And here, we're familiar with what the graphs look like, so we're able to look at the graphs and see that we have that type of symmetry. What we want to do is be able to look at an equation and try to figure out how would I know whether that equation has this type of symmetry. So the idea is here, and let me draw this parabola a little bit better so that it actually looks symmetric. That was a very bad freehand graph there. That's a little bit better. Okay. The basic idea here is that if I have a point x, y here, it's almost like the y-axis is a mirror, and that point can look in that mirror and see its mirror image on the other side. And what are the coordinates of this point? Well, we've got the same y value, but we're going to have the opposite x value. And one thing I want to point out here, as I've drawn this, I chose my point xy to be here in quadrant 1 so that x and y actually are positive. I could just as easily have chosen a point in a different quadrant. For example, if I choose this as my first point on the absolute value graph, I can call that xy. Remember, there's nothing inherent in the names x and y that tells us whether they represent positive or negative numbers. So in this case, my y value is still positive because we're above the x-axis, but x would be representing a negative number. Okay, but the same thing holds. If it looks in this mirror on the y-axis, it's going to see its mirror image point on the other side. That point has the same y value, but the opposite x value. So, a graph is going to be symmetric about the y-axis if this is true. If xy is on the graph, so is the opposite of x, y. So let's just take a look at an equation and see whether the equation describes a graph that would be symmetric about the y-axis. So let's say I had something like x squared plus y cubed equals 5. So here's an equation. This one I think I could solve for y, so this one does represent a function, although it's not in standard form for that. So what I would do to test for this symmetry is I would say, if xy is on the graph, that means, let me write this. Now, if I suppose that a point xy is on the graph, then for that particular point, xy, that makes this equation true. So then x squared plus y cubed equals 5 is true. That's a true equation. Because remember, the relationship between an equation and a graph is that points that make the equation true are points that are on the graph. Points that make the equation false are points that are not on the graph. All right, so now I want to ask, is the mirror image point that has the opposite x value but the same y value on the graph? Well, what I'm going to do is I'm going to plug this in. So I'm going to replace all the x's in my equation with the opposite of x. I'm going to keep y the same. So if I did that, I'm replacing the x's with the opposite of x. I'm replacing the y's with just y. I'm not doing anything there. And I'm checking to see whether I get an equation that I know is true. The only equation that I know is true is this. So I'm going to simplify this and see, does it simplify to the original equation? So let's see. When I square this here, if I have a negative x, there's this negative sign, but I'm going to be squaring that. I'm basically going to have a negative x times a negative x. Those two negative signs will cancel. So I'm just going to get x squared plus y cubed equals 5. So this graph I know is going to be symmetric about the y-axis. Now let's take another equation. Let's suppose I had x cubed plus y equals 4. All right, so I'm going to suppose that xy is on the graph. Now, if I suppose xy is on the graph, that means that x cubed plus y equals 4 is a true equation. Now, you don't need to write this out every time. I'm doing this for our first couple of examples just to explain what the thought process is, why we're doing this, because it's a lot easier to remember what to do to test for a type of symmetry if you can understand why you're doing it. Okay, so now I'm saying, all right, if that point's on the graph, and I want to know if it's symmetric about the y-axis, where would the mirror image point be? Well, the mirror image point would be on the other side of the y-axis, so that would be the point that had the same y value, but the opposite x value. So now I'm asking, is the opposite of xy on the graph? So I take my equation, and wherever there was an x, I'm going to replace it with the opposite of x. So we get the opposite of x cubed plus y equals 4. Now if I have the opposite of x cubed, that's the opposite of x times the opposite of x times the opposite of x. Now the three x's are going to give me an x cubed, but the three factors of negative 1 are going to give me a negative 1. So I'm getting negative x cubed plus y is equal to 4. That's not the same as this equation. And this is the equation that I know is true because xy was on the graph. This is a different equation. So when I plug in the opposite of x plus y, I do not get that true equation. So this graph is not symmetric about the y-axis. All right, so that's our first type of symmetry, is symmetry about the y-axis. I'm going to talk in the next video about the other types of symmetry that we have, and then we'll practice testing for all three of those types. Now, there is a worksheet for this section. I didn't put all the questions that I'm going to ask you to do on that worksheet. I basically created the worksheet so that I could write down the problems that it takes a lot of time to copy, or the problems that involve a graph so that you'd have a nice, neat picture of that graph. But probably in the next video, I'll ask you to do some problems that aren't on the worksheet. So just a heads up that sometimes when I give you a worksheet, every problem that I'm going to ask you to do is on the worksheet. Sometimes when there are problems that I can write down really quickly here on the board and that you can copy just as fast, I'll just do that. Okay. Nothing for you to do right now, just tune back into the next video and we'll keep going.